Hello there. In this video we're going to have a look at permutations question where we're arranging people in a straight line. The important thing to remember in these questions is that if there are any restrictions imposed on the ordering, you must always deal with the restrictions first. So let's have a look at the question. In how many ways can 5 people A, B, C, D and E first of all stand in a queue without restrictions on their ordering? So if we imagine the 5 positions, well, to fill the first position, we could fill it with any one of the 5 people. Then there would be 4 people left, then 3, then 2, then 1. So we just multiply them all together. So really what we have is 5 factorial ways. The next part, how many ways can they stand in a queue if C and D must stand together? So what we do is we'll list the people A, B, C, D and E. And if C and D must stand together, well, really, we'll tie them together and treat them as one object. Now all we have are just 1, 2, 3, 4 objects that we want to arrange in a line. And we know that we can do that in 4 factorial ways. But then we've also got to consider the fact that C and D could be rearranged in 2 factorial or 2 ways. So we have to multiply this answer by 2 factorial. The next part, how many ways can they stand in a queue if C and D must stand apart? Well, we know the total number of ways we can arrange the people is 5 factorial, and we know that the number of ways we can arrange them if C and D stand together are 4 factorial times 2. So the number of arrangements where they must be apart is just the difference between these two answers. So it's 5 factorial minus 4 factorial times 2. Okay, for the next part of the question it says how many ways can we do it if they stand in a queue and D is at the front and A is at the rear? Well, if D is at the front and A is at the rear, we really only have one way to fill each of those positions. And then all we have to do is rearrange the people in the middle, and we know that we can arrange these 3 people in 3 factorial ways. So the answer is just 3 factorial. And the last part of the question, similar to part C, except this time we've got, similar to part B, except this time we've got A and B together and D and E together. So again, we can list them out, A, B, C, D, and E. And if A and B are together, we treat them as one object. If D and E are together, we treat them as one object. So really what we're doing is we're arranging 3 objects, and that can be done in 3 factorial ways. But of course A and B can be arranged amongst themselves in 2 factorial ways, which is just 2. And D and E can also be arranged amongst themselves in 2 factorial ways, which is also just 2.